Okay, that's it. I hope you guys enjoyed the tutorial, and I will see you guys next time. Okay, so let me just finish you guys enjoyed the tutorial, and I will see you guys next time. Okay, that's it. I hope you guys enjoyed the tutorial, and I will see you guys enjoyed the tutorial.
And let me put a link.
See you guys next time.
Let's see. Actually, for this part, we're gonna go through probably like 2 parts that I would normally do like on video. And I think, at least for this part, it's pretty simple. I don't really think we need sample code for this one. But for the next part, I'll link to the tutorial so you guys don't have to like write out all the JavaScript, because nobody wants to write JavaScript. So anyway, let's see. So first of all, it seems like there's a lot of people. Oh, is there an echo going on? Can't hear it. I have my sound muted. I'm not really sure why I would echo.
But for the next part, first of all, it seems like there's a lot of people write out all the JavaScript going on. Nobody wants to write JavaScript. Can't hear it.
Still?
Anyway, so I have my sound muted. I'm not really sure why. It seems like there's a
plug
lot
in
of
some
people.
headphones to hear it.
Is there an echo going on? Can't hear it.
Is it still echoing?
Sound muted. I'm not really sure why I would echo.
Man.
So first of all, it seems like there's a lot of headphones. Is there an echo going on? Still? Is it still echoing? Sound muted. I'm not really sure why. It seems like there's plug in some headphones to hear it.
Still echo.
It seems like there's a lot of headphones.
Your voices.
Is it still echoing? Still? I'm not really sure why I would echo.
Man.
Is it still echoing? Sound muted. So first of all, it seems like there's a plug in some headphones to hear it.
Still echo.
Still?
Your voices.
Is it still echoing? Still? I'm not really sure why I would echo.
Okay, how about now? I deleted system 32. Are we all set now? Okay. I don't really know why it was echoing. I think because I had desktop audio on, but like my audio is muted, so I guess it just doesn't care if the audio is muted. Okay. I have to go back and listen to that one. Okay. Now, as we were saying, so it seems like, at least for a lot of people, there was a slight confusion on what TensorFlow.js actually is and like why you would use it over, say, just TensorFlow with Python. So the deal with like TensorFlow on Python is that in order for someone else to like run your whatever your application is that uses it, either you have to host all the processing power that's going to be required to run your application, or you need your user to be able to run those. So for example, I think it was before TensorFlow.js, or which was before that, deeplearn.js, you had like TensorFlow Lite, and that could run on like a Raspberry Pi or theoretically a phone. I don't really think I ever saw anybody running it with a phone. But you could do that, but the person would need to install TensorFlow for that to work. Whereas with TensorFlow.js, you can run that in the browser. Anybody can run it in the browser. There's no installs required, and it just happens immediately. So the reasons why you would use TensorFlow.js are a little different than why you would use TensorFlow in Python. So like the first thing is, let me pull up an image, see if I can get this copied over. You should be able to see that. So these are like these are the runtimes of TensorFlow.js versus just regular TensorFlow. And these are just inference times over like one, is it echoing again? Don't tell me that. I'm only going to believe Scott if I see echoes. Anyway, for a single inference, like it's, I don't know, like 3 to 4 times slower on TensorFlow.js than just regular TensorFlow. But these are milliseconds, so you can still make, even with TensorFlow.js, a 10 millisecond or really 11 millisecond inference with TF.js if your client's on a 1080, which they probably aren't. They're probably more likely just on a regular CPU. But even then, a 56 millisecond inference is really no big deal. As compared to, say, even like on a laptop that's still running just a regular CPU, it's not even twice as slow. It's just a little slower on the GPUs. And they do this running off of either your CPU or WebGL. So, and that'll run on your actual GPU if the client has a GPU good enough to run it. So it's not like you're still going to train your models with like if you're going to make a big model that's using like a ton of data, you're not going to do this on your client GPUs. Like you're not going to do it in the browser or anything like that. But it's when you actually go to like run the inference, or if you're going to do something more like transfer learning or something like that. So, so really, to me, I think people are going to be using TensorFlow.js kind of alongside TensorFlow. You're not really going to be, replacing one for the other. That doesn't really make as much sense to me. Like you're not going to train large models with this, except in the case where with like TensorFlow.js, you could do very large distributed learning that you really were never going to be able to do with just regular TensorFlow. So you can do stuff like that. Also, you could do like distributed just data collection, for example, just where you're collecting a bunch of data from different users. And like with object detection, for example, a lot of users might do custom objects or something like that. And before you know it, you've got quite a few objects that have been customized by user, but you've got, maybe they're just doing like 5 or 10 or something, but after a while you've collected, I don't know, hundreds of thousands or something like that. So there's a lot of stuff coming in with TensorFlow.js that honestly I don't think anybody can really predict where exactly it's going to go. But to me, I think probably the big thing is just transfer learning with it. So anyways, that's a little bit about TensorFlow.js and the speeds and why you might use it. The other interesting thing is like even just like little stuff like right now, you run ads to monetize a website, whereas instead of ads, you could be training models to do who knows what, whether it's detect cancer or something like that. Like you could be doing so much more productive types of things. So anyways, that's that. And what I'm going to go ahead and do is I think we're going to at least start in just a little Sublime Text just to give us the basic HTML stuff that we need. And then otherwise, we're just going to hop into our browser. So I think I lied. I'm not going to make everybody type out these tags. So let me put a link to the tutorial in the description. I'm banning for anybody saying there's echoes. Can you host Python models? Yeah, so with TensorFlow.js, as far as I know, there's no real easy way to do it with like a raw TensorFlow model, but people are doing it with like Keras models. So TensorFlow.js has kind of like 2 major layers. There's the core API and then there's the layers API. And the layers API is more of like your high level where you're just going to write one line and it's like basically a function with parameters. And that's one of your layers. So it's very similar to, doing something with TF-Learn or Keras for that matter. It's almost a direct translation. So anyways, here is the link to the text-based version. And all I'm doing is just copying and pasting that HTML block. So it's just that HTML. And then we just bring in this script here. So this is basically all you're going to have to do if you want to use TensorFlow.js. You just need to bring in the actual script. So I'm going to go ahead and save that. And let me pull that up. What if I just kept the screen hidden for the rest of the tutorial? Let me fit this on. So at least in Chrome. So I've some people were complaining about when I put up a link to like a Pong AI example. People were saying it didn't work in Firefox, I think. So if you're in Firefox and this stuff isn't working, get Chrome. So once you're in Chrome, just press F12 for the console. Let me see if I can just do this. And we'll just bring that up. So basically making models in TensorFlow.js is very, very similar to what you would do in like Keras. It's pretty much modeled after Keras. So you're just going to start with your constant, and that's going to be model. And then, I guess because I've typed this in before, it already knows what I want to do. tf.sequential. So this is just your typical feed forward neural network. Now you can do other stuff. There's tf sequential, and then I think the only other one right now is just tf.model. What about Internet Explorer? I actually think it works in Edge. I'm not sure about Internet Explorer. I think Edge and Internet Explorer are two different things. I'm not positive, but yeah. So once you've got your model, basically all this does is at least, I mean, you can write, I think it's the same thing in raw TensorFlow, where you could write very general, you could say a tensor is just a tensor, or you could say a tensor is a 2D tensor or a 3D tensor, or you could just say like tensor and then maybe give the shape of the tensor. So there's a lot of things that you can do. You can be very general, or you can be extremely explicit. And in general, if you're writing raw TensorFlow, it's probably best to be as explicit as possible. Otherwise, you're going to probably get in trouble. So you could say tf.model and then define your model, and it would be all fine. But if you're going to do a feed forward model, might as well call it sequential, because that's what it is. So then when you want to go ahead and add a layer, you're just going to say model.add, and then you're going to add tf.layers.dense. And again, there's all kinds of different layers that we could add. Dense is just your regular, typical layer. And then you're going to specify how many units it has. Well, this is our first layer, so it's just going to be an input layer, so it would just have 1 unit, let's say. And then you're going to give the shape. Input shape camel case, now that we're in not Python. And then again, this is just a 1 by 1. It's just really a 1. So then that's your first layer. And for now, we're just going to do a simple regression, so it just has a single layer to it. So then we're going to say model.compile. And then in here, you're going to put any of the parameters that you want to compile with. So with loss, we're going to do mean squared error. And then you'll specify your optimizer. And in that case, we're just going to use stochastic gradient descent. And then you're going to have to start with some actual data. So we'll just do x's and y's. So with your x's, you're going to do tf.tensor. And again, these are all your options that you have right now. In our case, it's going to be a 2D tensor. So we're going to say for the x's, 1, 2, 3, 4. Whoops, what did I do wrong here? Oh, we didn't give our shape. So with the explicit tensor 2D, don't forget to specify your shape. In this case, it's a 4 by 1. Okay. So I don't even know what I'm supposed to do to overcome when you get this here. Maybe I'll just cheat and call it something else. Someone help me in the console. Why can't, I guess because I've called it a constant. I just figured if I hit an error, I could just redefine it. I guess not. X's too. Okay, that's how I'm going to do it for now. Someone let me know. There should be some way to go back, but I guess if you hit the error, it just doesn't care. Anyway, make sure I'm not off screen. Cool. So then we're going to do constant for y's is equal to tf.tensor 2D. And then again, in this case, what I'd like to do is try to make it something that we can actually know. Is it going to, yes, I could have. Can I define a variable after I've defined the constant though? Because I can't go up here and edit this. Like I've already defined. So I don't think I can get away with that. Yeah. I think chat is just too far delayed. I've already solved the problem. I wish I could set, in the other live version, I could set latency super low so chat caught up super quick. But nope. Oh, just say X. I can't modify it because it was a constant. Can't do that. Anyway, so anyway, we want to have some way to verify whether or not this model actually works. So all we're going to do is this is going to end up making a linear, just simple linear regression. So what I'm trying to do is we're just going to multiply by 2. So we're just going to say 2, 4, 6, not 98, 8. And then again, we're going to say that's a 4 by 1. So now we have our x's, our y's. The next thing that we need to do is just a model.fit. And then again, x's, y's. And there's other things that we could pass in here, including like epochs, stuff like that. For now, we'll just fit. Oh, of course. X is 2. There we go. And what we get back is this like promise. Now, I'd never really heard of promises until I started messing around here. Basically, a promise is just a thing that may or may not return something later. So sounds like asynchronous stuff. So yeah. Anyway, it should return pretty darn quick. In this case, it's just like a simple model. And I'm not even sure, like I'm guessing maybe this would say unresolved or something like that while you're waiting. Nice, Scott. But anyway, basically immediately says resolved. But when you actually go to write a real model and like with a real application or something like that, you need to wait for the model.fit to occur before you actually go and use it. You wouldn't want to start using it just for all other, just same thing as any asynchronous stuff that you might be doing. If you need to wait for it, you need to explicitly wait for it. So once you've done a fit, you can do a model.predict. And again, you're going to do tf.tensor, and we're going to predict against tf.tensor. And in this case, tensor 2D, let's predict a 5. We're going to say that's a 1 by 1. And you'll see that you get, I don't even know what you would call this. I'm not sure that we got this right. But so at least for sure, anytime you do this, you're not going to get anything back necessarily. You have to, no different than really TensorFlow and Python where it's all kind of abstract. You have to bring it out. So let's, run it. There we go. So we can use .print if we're in the console. That's not really going to help us when we're actually writing the code. So instead, you're probably more likely to use data sync. So it's data sync like that. And you'll get your actual output. So in this case, it was a 9.02. Not quite what we were hoping for. We were kind of expecting that to be a 10. So instead, what we can do is we can fit this, what's on top of my screen? Another screen. So instead, what we'll do is we'll go back up to model fit, and we're going to say epochs 100. So this time, rather than just doing one epoch, we're going to do 100. And in fact, let's do 10 first. 100 might take a second. We'll do 100. That should be pretty quick. I think it's like 1,000 or more. It might take a while. But anyways, we'll fit. Okay, that's already done. So then we're just going to do the same prediction again. And as you can see, we're getting much, much closer to 10. Eventually, this should be totally solvable just with if you're just making a linear model, you're probably not going to, you're not going to really have to worry too much about the overfitment in this case, since it's perfectly linear. Let's try 1,000. So in theory, this should be 1,100 total, maybe 1,110, or no, 1,101 because the other one was only 1. So anyway, we're getting a little closer to 10. Eventually, we should get like 9.999999. But then we could say, for example, model.predict 7. That should be really close to 14, and so on. What notebook is this? This is a Chrome console. Okay, so up to this point, that's like just a really simple example of doing TensorFlow.js in the browser, just doing like simple linear regression. But but there's so many other things that we still definitely want to cover. So the next thing we're going to do is work on just like a simple web app. But first, I do want to bring up the actual docs here. So like I was saying with like the tensors and the layers, there's just a bunch of different options that you have to do. Like these are all your different tensors. You've got classes, transformations. I'm trying to get it. So the model, you've got just a regular TF model or the sequential model, which is what we're dealing with right now. Continue down. So then with the layers, we've been using dense, but you can obviously use a whole bunch of other layers. And then even though there's like a dropout layer, you can also add dropout later on. So you don't necessarily have to do it all within one layer. And I'm trying to think if there's anything else I really want to bring up here. I don't know if they have their little tidy. They do. So it's also not the greatest on memory. If you leave it running long enough, you're just going to slowly like exhaust all your memory. So you also want to use tf.tidy. I may or may not cover actually using it, but you just need to use that once in a while if it's like a long running thing, if people are going to keep using it. At least for everything I've written so far, maybe I'm just bad. But it eventually, if I leave it running in the background and I forget about it, eventually my GPU just crashes. so don't forget to tidy up from time to time. Okay, so I think what I'll do is I'll stop here for a moment, and if anybody has any questions specifically up to this point, let me know. And then let me get started on pulling up the next part. When it comes to JS, coding training is much better. I would hope anybody who's actually doing JavaScript pure tutorials would be better. I like the echo meme now. Thanks, guys. So for the next little bit, we will work pretty much directly in the HTML file. I just think working in that console, at least when you're just trying to make a basic model like that, I think that's a little simpler than working in the HTML file, running it, working a little more, running it, and so on. Sorry about your Discord, Scott. Okay, so now let me pull up as soon as I find my mouse. There we go. And here is the link to part 2. What about TFJS and Node? What about it? Okay, so now we are going to just work straight out of the an HTML file here. Let me move this over. And basically we're just going to start with the same thing, pretty much everything. If you're going to start using it, you're just going to stuff in the script tag here, and then you can start making use of TensorFlow. Now the other thing I'm going to be using here is I just needed something to make some charts with, and I just found chart.js. I don't really know much about chart.js. I just found it. I can make charts with it. Done. So that's what I'm going to be using. Again, you don't really even need to necessarily go there. If you're a little confused about how I'm making the charts or something, you could check out their documentation. But I personally didn't find the need to do it, and I'm an idiot with I'm an idiot with TensorFlow too, but mostly with JavaScript. So hopefully everybody can follow along. If you got questions, put them in the chat. But anyway, so the only other thing that we need to bring in is going to be there. So we're just bringing in the charting stuff. So the idea here is to get us to the point where like a user can actually interact with your application. So in our case, what we're going to do is just try to let the user input some data, and then can we fit to that data? So in a lot of applications that you're going to do, if you're going to be using TensorFlow.js, chances are, and you're trying to do it in the browser, chances are you're going to be doing it for some sort of interaction. You're not really just going to be, they're not going to open up a console. Okay. But you could also, like, definitely people might, like, some things are so useful, like, for example, just general object detection, for example. You might not take any input other than maybe from the camera of the user or something like that, but you're not actually going to try to fit to their data. You're just going to predict their data or something like that. Anyway, so what we're going to do is between the body tags, we're just going to take in a couple of inputs here. So input, and we're going to say type is text, ID equals X, and that's it. And then we're going to do the same thing for Y. I actually don't know if type should be text or if we should change that, because actually it's not text really. We're trying to input numbers. Like I said, I'm an idiot. So if anybody has suggestions on these, by the way, feel free to post changes to the scripts in, I think you could just paste bin into the chat. Otherwise, I could put them up on GitHub or something, or you could put like a gist or something like that. Anyway, we're going to go ahead and save that real quick. Let me make sure that's working how I intended. Sure is. Okay, so the other thing, let's do X colon there, Y colon there. Why did it? Oh, I didn't save it. Okay, great. So we got some beautiful X and Y input that we can take in from our user. So then what we want to do is we need to have like some sort of submit button, type equals number. Let's do it. Thanks, guys. So now what we're going to do is input, again, type in this case, it's going to be a button, and comma, ID equals append. So we're going to tie in some fancy JavaScript to that ID there. And the value will be submit. So like once a user actually puts in some data into these inputs, they're going to click a submit button and be done in front end. Thank you. I am pretty good. Great. So now we've got a submit button. Is Daniel here? I didn't see Daniel here. Yeah. Daniel's waiting for his JavaScript to show up. This is still my JavaScript. So anyway, so then we have like this the actual chart stuff. So again, I did put the link in the chat, but it's kind of disappeared. So just in case at this point, again, there's the link. So what I'm going to go ahead and do is just copy this in. No reason to write out these tags. So in this case, this is just getting ready for our little chart. It's just a little div that's going to have some canvas information, and this is all just where our chart ends up going. So then, once we've got a chart, we're ready to start populating that actual chart. So what we want to do is start with some script tags. And again, in this case, we're just going to need some X's and some Y's. And our goal is to just take whatever the user inputs to the X's into the Y's and populate these. And then using these, graph a chart. So to do that, let me see. I'm actually going to take this chunk here, and then I'll explain the chunk after that. Hopefully that'll go right in. Cool. So whenever someone actually clicks this ID, right, that's our submit button, we're going to run the following function. We're going to grab the value for X and Y, and then we're going to append the value to our little arrays here, X's and Y's. So then, once we've done that, the other thing, you don't really have to have this, but I tried to find a way where I could just automatically update X so I didn't have to do it myself, because generally you're going to do like 1, 2, 3, 4, but maybe you don't want to do that. Anyway, so this is what I did. I don't know if this is the proper way to do it, but that's what I did. So once we've got that, the next thing we want to go ahead and do is add in our chart. So let me take, ooh, this might get messy. So now this code is all like chart.js stuff. Yeah, these little things are off. Or is this part of our function? Oh, I guess it's not off. It's part of our function. So in this case, all we're going to try to do, hopefully at this point, is plot the data that the user puts in. So let me refresh this and see. 1, 5, submit. Okay, great. So as you put in some new data, it's just going to graph that new data for you. Welcome to JavaScript 101, everybody. I hope you guys are enjoying the tutorial. So once we have that set up, also I didn't know this was a thing. I'm pretty sure that's just like put in there by Chrome. I feel like that's brand new. I didn't notice that when I was doing the development, but probably not. Anyway, once we have all that, we want to actually start creating our model and doing all that kind of stuff. And doing that's pretty much what we've already done. So in this case, I'm just gonna take this and actually I'll copy from here. So this is the model code that I'm adding in. So basically our X's stay the same, the Y's is what we're trying to fit to. So this is our best fit, and then this is our model. All this stuff is the same. This is just me poking around with the layers. No necessarily great reason to be using those. I was just trying to try different things. So as usual, you need to pay attention to how much. So your input layer itself. So if you're going to do a purely linear model, your layer unit will be 1. But so at least here, it doesn't appear that you really necessarily need to have an input layer. Your input layer just is your data. But then you still want to have the output layer defined. The only thing you have to watch out for that for some reason hasn't thrown an error on my end, and I can't figure out why it doesn't throw an error. But so for example, we're saying this is 128 units in this layer, and the input shape is 1, right? And then down here, you're saying, okay, again, we have 128 layer, and the input shape is 128. Now, strangely enough, you can have the, at least historically, we could try it if I remember to. You could have that say something else, and it doesn't throw an error, and I'm not really sure why. And it's really hard to debug it when your model's not really working right, and you've got some sort of error like that. So for some reason, like I said, I've been able to get away with that and not really notice that something is wrong. At least in the code, it doesn't throw an error. So once we have done that, the next thing that we need to do is we need to fit the data and then draw the data basically on a graph. So I think what I'm going to do now, rather than try to manipulate that live, is I'm just going to take to the end here and then explain what we've changed. I think I also must have, oh no, it's here. Okay. Paste. Okay. So now still the same thing is going to be happening. Once you click the append, we run the function. We're going to go ahead and every time someone clicks the submit, we're going to add that 1. And then now the graph code is happening inside the statement after the fit. Again, this is probably not the ideal way to do it, especially with chart.js. Chart.js has like I think it's like chart.update or something like that. Like it has this little update method like that. So I'm pretty sure if all you did was update the best fit rather than redrawing the chart, it might do it a little more optimized, a little more efficiently, but I don't know. I don't have the answer to that. I also don't really care at this stage. So anyway, coming in, basically what's going to happen is whenever they do click the append button, we're just going to refit to whatever data they pass. And what you need to do is, like in this case, we have this, we're using .then, and this is why, like we have to wait for the fitment to be done. So like, for example, if you did like 10,000 epochs, that would take, I don't know, like a minute or 2 minutes to actually finish. So you wouldn't want to draw your graph before this is actually done. You would never see any updates. So you have to wait. And the way that we're doing that is just with .then. Then we run the function. And in this function, we're just asking it to predict the best fit line and then draw the graph no different than before. And like I was saying, hopefully like this chunk of code here isn't confusing. It's just a bunch of options. But if it is, this is just chart.js. Like there's really nothing fancy going on here. So now let me save that. Let's see if we are hitting any issues. There's another little error that I do hit. I wonder if someone can solve it. But let me just draw this graph real quick. So 2, 4, 1. Usually, yeah, I'm not really sure what this is. It looks like some sort of chart.js thing, but skip of undefined. It might be happening because I'm doing this kind of hacky. I'm not really sure. Fitment. Anyway, so you can continue appending here, but someone tell me why that happens there. I'd be curious. So anyways, every time someone makes this submission, this line gets recalculated and our graph gets updated and all of that. Okay, so now, do we have any questions up to this point? And does somebody know why I hit this 1,000 times? Oh, even more times. Wow, it just keeps going up. Yeah, that just keeps going up. I'm not really sure what's going on there. This escalated quickly from a this is a number field to here's a machine learning model. Yeah. I don't think it did though. I mean, I feel like it's pretty simple stuff, and I would think that the stream would be ultimately very boring if I was writing out like this code here. Especially because I'm not a JavaScript programmer. You don't want to see me write this out. This took about 47 minutes. Doing it this way would have taken 4.5 hours. 2 import statements for chart.js? No. Just tf.js and chart.js. It stopped going up, though. Congratulations on your pregnancy. Never mind, it goes back up. Oh, there's a GitHub issue for it? Okay. Oh, it does. It does go up when I mouse over the graph. I guess it's like, is it for the tooltip part or something, or what? Come on. Yeah, I wonder why that's happening. Everything else seems to be working about right. I just really need to get this over 9,000 real quick. Done. You can be amazed if you type Alt F4. Yeah, right. So I'm definitely not seeing any questions on tf.js. And to be honest, that's basically all I really wanted to get through so far. So at least the next thing I want to go over with TensorFlow.js is the Pong AI game that we wrote. Let me pull that up. So in this case, this is just a model that runs, but we're still kind of working on this one. But you can navigate to Python Permanent/Pong AI if you wanted to play it. At the moment, all it does is run the model that was trained locally. But the goal would be to then, once you start playing the game with it, I hit the I'm not even trying. The goal would be to use transfer learning to then have the paddle either learn to beat you or just learn to play just like you. So you always have a worthy opponent that's not too good and also not too bad. But I think I'm going to save that one for either tomorrow or next week. I don't think I'm going to get on tomorrow, though. Occurs with mixed charts? You mean like if it has multiple lines on a chart or what? Nice best fit line there, bro. What? Why isn't it showing my line? Let's try again. I wonder why it goes off the screen there. What did I get rid of? Border width 1. I'm not even sure why it's going off the screen when I get rid of that line, but it doesn't seem to show up whenever I bring it up. Will you trade stocks in JavaScript? Absolutely. I'm already trading stocks in JavaScript. Yeah, TensorFlow.js can use the GPU as long as there's one available. The TensorFlow.js syntax is not exactly the same. I just wouldn't be. You've got just different naming conventions going on, but then also it's really more like Keras. Like it was built on top of Keras, or it was kind of modeled after Keras, I guess. You might, I don't know, maybe with the core it would be identical, but chances are if there's like some function that you can do in TensorFlow, so at least like when we were kind of messing around with the Pong example, there were a lot of functions that we didn't know how to do in JavaScript, but I knew they existed in TensorFlow, so I was like, oh, okay, we'll just use that. But then, for example, there was nothing for random. I didn't know making random in JavaScript was going to be like to like shuffle. I didn't know shuffling was going to be as challenging as it appeared to be in JavaScript, but that was hard. what's my trading strategy? Buy low, sell high. It's working out pretty well. So anyway, so I think I'll probably cut it here. I strongly suggest you check out the documentation for TensorFlow.js though, because like once you can just make a simple model like this, I mean, you could pretty much do anything. It's just a question of what can you do in JavaScript, and that's where the hard part comes in, at least for me. But once you've done that, the other thing that you can do is you can save, you can load models. The only challenging thing with loading models is it needs to, I guess, be on the same domain, I guess, as wherever you're hosting your little JavaScript app, something like that. I'm not really sure why you can't load it elsewhere, but maybe whenever we do that next one, someone can help us with that, because there's got to be a way to load the model not from the same source. Need machine learning self-driving car series from you in Unity or other simulator. It feels like we would just probably do the exact same thing. I'm not really sure why we would do that. How about beating Google's GoBot now? Possibly. Like, you can definitely, like, that's the kind of stuff I think that, maybe not beating Google's GoBot, since most of the people that would train the GoBot would not be like Go experts. But you can train models, like distributing the actual training is, I think, something that's going to be super valuable with TensorFlow.js. Also, like, we currently don't really have anything that distributes inference. Like, we've never really, other than like an application, but that requires a very large like central server to do the inference. So that's like do the actual predictions and stuff like that. So like right now, no one's ever really done that, because that's really never been like a monetarily feasible thing. But as long as you can, hey Siraj, as long as you can run it like on people's devices, I just think that changes so much, because even just like the chatbot, for example, that we run, it's a lot of fun, but at the same time, each inference, even on a pretty large CPU server, takes about like 6 to 12 seconds. Whereas if you could distribute that on everybody's devices, I think that just makes a huge difference. I wonder if you could compile TensorFlow.js models. So I'm not really like, so with the TensorFlow.js model, you can convert it into and out of TensorFlow.js to like run with Keras, but I'm not sure about anything else. But if you could convert it from Python to your WebAssembly, you could. Everybody's getting trolled by fake Siraj over here. Is it possible to create object detection? Yeah, you can. There's a pretty decently developed object detection with TensorFlow.js. Like, that already exists. I can't really show it because I'm using the webcam, but that works. So the only thing that's kind of a bummer with TensorFlow.js is like, so this exists. I'm pretty sure this is the one. Yeah, so you can head. Shoot, they had a demo. I must be missing it somewhere. Oh yeah, here we go. Here's the live demo. I can't pull it up because it's using my camera right now. But yeah, you can run this. I wouldn't suggest doing it on your phone, but you can run it on your computer, no problem. So yeah, that's, well, sort of a problem. It's still pretty slow. I'd be curious what people without, like, I run it on a 1080 and it's it's okay. But then I tried to do it on my phone, and although it was an older phone, I just got a new phone. I wonder how it would work on my current phone. But that's kind of the bummer, is like, you know, the TensorFlow.js was kind of marketed as being something you could run on like anywhere easily, but really it's almost like the technology is way ahead of the hardware, as has honestly been the case with deep learning since like the 1940s. So, but it's here waiting. But at least for me, I couldn't run this demo on my phone before. How many objects? Infinite, as many as you train. I don't know how many exist in Tiny YOLO, how many objects they have, but it definitely, like, you could train it to detect whatever you wanted. And the whole point again of TensorFlow.js is that someone could say, here's a speaker, boom, use transfer learning and train that. And then you could let people submit that data back to the main one, and then but now you could start adding that to some sort of global model. Which programming language I suggest? It's whatever programming language you can make cool stuff in, and whichever one you enjoy working with. So I'm gonna look this up on my phone and see if I can get someone let me know how it runs on your computer, especially if you have like not a good GPU. TensorFlow.js. Live demo. How would you handle corruption of data? I mean, that's a good question. You would just have to hope that most people would not send in crummy data. You could also have people like it's like if people were using it, they can either say, hey, this is a good example, or no, that's not right, that's not the model. Man, it's not loading the... I can't even get it to load on my phone. TensorFlow on Scratch. Yeah. No, I hope not. I don't know. That could come though. I can't imagine it's too far from being possible. Damn that model, 40 meg. Yeah. It's not loading for me. I can't even get it to load on my phone. It just hangs. So here's a better question. Oh my gosh, it's Sentdex. Can anybody get this to load on their phone? It should pop up with like a question if it can use your mic or your camera rather, but mine doesn't even come up. They've done it already? Is that in response to Scratch? Is it on? No way. Now I gotta look it up. Scratch, TensorFlow. So by the way, TensorFlow.js tutorial is over, so if you want to skedaddle, have at it. I see a Medium post. No. Wait. No, this is from Scratch. No. I got too excited. TensorFlow is it just deep learning model in Scratch, or is it TensorFlow in Scratch? With Scratch. Deep learning with Scratch. I demand a link if that's possible. If you can't, I don't know if people can put links in this chat, but if you can't, come to the Discord channel and put a link in. I'd love to see it. Moto G4. I'm trying. Oh, it just finally came up. So I'm on my S9. Let's see. Allow. That took like, I don't know, 5 minutes to load the model. That was pretty brutal. Now I need something that it can detect. I'm not really sure what this thing detects. Ooh, that's not bad, actually. So when I did it on my S5, it was pretty slow. I mean, I'm getting about 2 frames a second on my my Samsung S9, but that's not bad. It didn't run on my other phone, but it actually runs on the phone now. So that's pretty impressive, actually. And I know you can play, there's a couple other things on, if I go to TensorFlow.js. Oops. I'm not actually going to run it. Oops, that's not what I wanted to do. Where are the demos? There's like the one with let's see, getting started. There's the one with like Pac-Man and stuff. That one was pretty cool. Is this going to be a series? It'll at least be one more live stream and probably, I don't know, 5 videos or something like that. Get an iPhone? No! Never. So here's the issue I have with iPhone. Although Samsung's really the same. So with the S5 was my previous phone. All I had to do is like pop off. I'm not going to run it. Runs it. I didn't think it was going to be I'm not sure what you're talking about, man. I didn't think it was going to be possible on the phone, but I just left it up and it finally came up. So with the S5, right, you can pop out like your battery and just replace it. On an iPhone, you have to make an appointment to go to the store just for them to diagnose your phone as having battery issues. And then you need to make another appointment to go back to the store to get it replaced. And really, it results in you having to go to the store like 3 times because you got to go to the store, make an appointment to go to the store, drop off your phone, and then come back to the store again just for a battery. It's absurd. Oh, and you pay $100. Oh, here's the demo. Just go to the front page and scroll down. So if you haven't done these are actually pretty cool. The Pac-Man one's pretty cool. I haven't even done the teachable machine. PoseNet's all right. Although maybe other people will find them more interesting than me. Don't touch the battery on a Samsung device. On the older ones, it was super simple. Just pull it out. Just pop off the back. Now the new ones, you have to stick them on a hot plate and wait and pry them apart. But at least on the Samsung device, you can still do that. Whereas like on the Apple phones, you're going to probably break one of those cables when you pull it apart. It's as if it was built to be. I do have unresolved issues with Apple, Scott. It's the one time I tried to replace an Apple phone's battery, I like opened it up and there's the like cable like right there on the side. It's like built that if you're using something to like pry open the phone, you're going to hit it. And from then on, I've hated Apple. I've never owned an Apple device either, though. I thought you said how to obtain casualty data. Whoa. Is there a good library tool way to visualize machine learning models? TensorBoard? That's basically it, man. And that's like for example, we were trying to train the Pong AI model, and there's really like training it. You can do everything in TensorFlow.js, but visualizing the training is just not a thing in TensorFlow. Unless I'm mistaken, it totally might be. But the model just wasn't working, couldn't figure out why. So what I ended up actually doing is taking a bunch of training data, training it in Keras, visualizing that in TensorBoard to get the model to actually just create the model that I wanted, and then exported the model and then used that in TensorFlow.js. I think that's probably the way that most people are going to wind up using TensorFlow.js, which is why in the beginning, it's not really a TensorFlow in Python versus a TensorFlow.js. You're going to be using both of them, especially if you're training large models. You're just not going to train a large model in TensorFlow.js unless you're like distributing it or you're making custom models for everybody. But again, that's kind of the beauty of TensorFlow.js is everybody can have their own customized machine learning algorithm that's catered just to them. And historically, in order to do something like that, you couldn't do that. You just couldn't have something like that as part of your business model. Whoa, another Sentdex in the chat. What are the odds? What are the odds? Anyway, yeah, I think that's it. What's epoch? Iteration through data, like your training data. One full pass. To be honest, I have not seen like super impressive TensorFlow.js use cases yet. Like some of these are like kind of out there thinking, but at the same time, not really super groundbreaking. I'm still waiting to see someone do something super cool with TensorFlow.js, but I think that it's going to change a whole lot of stuff. I think most people are still kind of thinking of TensorFlow.js as like TensorFlow in another language. I don't think that's it. What's next for Pong AI project? I don't know if you mean like in the series or not, but what's next is finding a JavaScript version of Pong. Already done that. Copying and pasting that in, taking that data from Pong, and using that as training data for a model. And then from there, saving the model, loading the model, and then also like training the model off-site, because you can train it in Keras, and then you just export it to a format that TensorFlow.js understands. Basically, username, anything you can do in TensorFlow, you can do in TensorFlow.js. At least as of a while ago, the API coverage was like 90%, and now I'm sure it's just only grown from there. So anything you can do I would probably say anything you can do in Keras, you could do in TensorFlow.js. Probably 99% coverage there. You don't have to charge battery on iPhone. Okay. Movie dues speed up your... I have no idea what that is. I'd have to like Google that. I'm not sure what that is. I think that's a typo. Notcha. If you want me to create a simple ML model with TensorFlow.js, just like go back in the live stream. We did that already. We created 2 models actually. How to detect an untrained image as an unknown image? I mean, it wouldn't have a, it's not labeled? I'm not sure what you're asking. You'd have to have another model that could tell you whether or not it missed a label or their object isn't actually there. No sponsor button for me. Why is that? Oh, you mean that beautiful blue button underneath the video that most people could see and you could just click and sponsor the channel? Some people don't have that button. I think if you live in like certain countries or something, you don't have access because it's, I don't know, Google is not feeling like doing the money for it. I don't know. Oh, speaking of which, with TensorFlow.js, so for example, Chrome just crashed on my phone. And that's what I was talking about before. Eventually, if you don't take great care to clean up your application, it's going to crash. And that only took like, I don't know, 10 minutes to occur on my phone. It didn't take very long at all. How do I land a job at Google? do good in school. Or if you do a lot of searches on Google for like technical questions, eventually you'll get like a I don't know what to call it, a challenge. And then complete that challenge, and then you'll get your interview at least. That's probably the most surefire way to get it. Do lots of technical searches on Google. My screen popped out from a growing battery on an iPhone. That's just an old battery. Nope, I don't live in Texas anymore. Sad. What do you do with drones? Whatever they say. You don't defy them. What was your GDP? I'm not sure that's a question you ask people. It's an interesting way to phrase it. What is the differences in the link in projector.tensorflow? I don't know. What is that? I'm not even sure what that is. Projector. New sponsor, Daniel Cucchiello. Welcome. Who is your biggest inspiration for ML stuff? I honestly don't have somebody that I would pick for that. Why move? So my wife graduated medical school and it started in residency in Alabama. So we had to move. Planning to go back to Texas, but we'll see. Oh, movie does? I feel like I just Googled that. Is that the, I hate to be wrong. Is that the, are you spelling that right? Isn't that the Movidius? Movidius? I think you're talking about that mic. Is it micro? Or no, it's Intel. Intel Movidius. I honestly haven't used one, so I couldn't tell you. I will say those. I've used a couple of their like little compute sticks. Those like Intel compute stick things. Those are pretty crazy. They pack a lot, and they're like on par with like the those NVIDIA. They're like dev kits. I can't think of the name. Like the Tegra dev kits and all that stuff. Alan Wang, thank you for your sponsorship. They're like better, and they're like a tiny stick. I don't know how they're doing that. Although I mean it's not as functional, so I think it just like plugs in via USB. Or no, I think the one that I used had I think it had like a HDMI plug on it. Scoot boot. Everybody make sure to talk to Scoot Boot. There is no back page. I think Daniel's sponsored just for the Scoot Kappa. So you can see. Let's see if it's still doing it. No. See that lag? That's because it's slowly but surely about to blow up my GPU. Probably the stream's just going to cut out randomly. But yeah, it's like super messy, and it's super hard to keep that from happening. Oh yeah, I was going to go to projector.tensor. I don't know what you're talking about with projector. Can you put like a link or something? Oh, here we go. Embedding projector. Is this not like the projector that's in TensorBoard? Like these are two totally different things if that's the case. Like projector is just for visualization purposes. So like if you're trying to figure out like what's going on in a model or something like that, like we use these for like the word vectors in the chatbot, so you can see like related words. Yeah, and this actually looks like a word vector. It's exactly what this is. Anyway, so you can see like related words, for example. What was my GPA? Dude, not the greatest GPA. I didn't actually do that great in school. I just never did homework. So if you gave me, I did good on tests, but if you gave me homework, I just didn't do it. I felt like if you're gonna spend like 8 hours at school, when I get to come home, it's my time. Thank you, good sirs. And probably the only reason I did good enough on my SATs just for automatic acceptance into the school that I ended up going to. Not a fancy school by any means, though. But yeah, that was it. Scott, how come the Scoot boot isn't working? Do you own a TPU? I wish. I even tried to get them to just let me use a TPU for a short period of time, and I couldn't. Mainly for CV. See, I've never used GPU, like OpenCV, like CUDA enabled CV, so I couldn't really tell you. The person you should ask for that is the PyImage search. I'm blanking on his name, but that guy. Adrian? I can't think. That's exactly what I think every day after school. Yeah. Especially because even at school, like, you do so much sitting. I mean, it's been a while since I've been in, like, especially, like, high school and stuff. But it's so boring. And the last thing I want to do is go home and do homework. Unless I was interested in the topic. But, I mean, high school is, like, the most soul-draining thing ever. Or middle school. Apologies to anybody who's finding themselves still there. Where's the guy's Twitter? I'm trying to pull it up. Adrian Rosebrock. Yep. That's who you should ask about your CV build. Probably a CPU intensive machine, but I'm pretty sure there's like CUDA enabled OpenCV now. So, but I'm not really sure if you can do that in Python yet or not. Python CUDA CV. Well, right now I think they're talking more about that dev kit. Let's see. Hey man, as long as you got a 100% on everything else, if it was 30% of the grade, no problem. Has anybody used a CUDA? CUDA CV? Speak of the devil right here. This is exactly why I tell you that. Just ask this guy. Compiling OpenCV with CUDA support. So yeah, I guess it would be a GPU machine, but like I said, I've never done it. I wonder how good OpenCV is once you use the GPU. The GPU is only going to shine if you're doing a lot of like small calculations, but a lot of the things that OpenCV is doing for you are like these like stupid little calcs, so it probably actually helps a ton. Is it possible to have a model that goes forward and backward? Yeah. Yes, sir. Can you load the PoseNet? No, I can't. Yeah, the thing I like about PyImage search is this. He's just like a marketing genius, because basically he just always has like his write-ups. He's got like full write-ups too, and like really holistic things, but he also just answers your questions. So you'll like search, like he's got Google search on like lock with OpenCV. Like, I don't know who's going to compete with this guy for OpenCV, but like every time I ever have a question with OpenCV, I just type it in and I always find this site with like an exact tutorial for what I need. What's that model then? Non-sequential. It's just not feed forward, that's all. There's a lot of models that you can go back on like that. It's just called bidirectional. I can't remember now. I don't know if Daniel's still in the chat, but I think the chatbot was a bidirectional. We tried so many different things though, so I can't remember if bidirectional was is where we ended or not. New sponsor, Lunster Full. Thank you for the sponsorship, good sir. Enjoy your emotes and your beautiful badge icon. At some point, right now, every month is like the same little icon, but at some point we're gonna change those. Someone was supposed to work on that along with the GTA trainer and a whole bunch of other things, but they're off doing who knows what, who knows when. Here's the next really important question. When you click on the emoji thing in the live chat, how do you get it to go away? Like it's exhausting most. Wait, maybe if I click. Oh, you just click back on the keyboard. Got it. Playing Factorio. Right. So I'm trying to see if anybody else has come up. Every time I search for like really cool examples of TensorFlow.js being used, it's pretty slim pickings right now. Although there is this one example. Whoa! Stock price prediction using TensorFlow. The issue with using deep learning with stocks is just non-stationarity of that kind of data. So that data changes over time. So like trying to fit time series data like stocks, where fundamental things are changing, is generally an unsuccessful enterprise. You could do certain things with it, especially if you're like trying to calculate like real value or something like that. But I think a lot of people make statistical mistakes when they're trying to use like deep learning or any machine learning to predict prices. Computes a factorial. TensorFlow.js is efficient enough. TensorFlow.js is extremely efficient. It's like 3 times slower, right? Or if you could get someone to run it on their desktop, it could be up to 3 times faster per single inference. I showed that picture initially. Let's see if I can find it. But it's definitely not slow by any means. Like it's a pretty impressive speeds already, and I think eventually the technology will come to get us to go even faster. But this was from the TensorFlow Dev Summit from 2018 when they first kind of were talking about TensorFlow.js. And these are single inference speeds on, I think it was like MNIST data or something. I can't remember what it was exactly on. But if the person has a high-end GPU, it's like 3 times faster to run it on their machine. But with like on a CPU, it's really not even twice as fast to run it. Like to just run it in TensorFlow.js, it's not twice as slow, I guess, which is pretty impressive considering, again, we're just using WebGL here. So that's that's pretty good. And like I said, the fact that you no longer, if you want to distribute some sort of deep learning application, you no longer have to host that model, which it's always a very heavy amount of hosting that's required. Like I said, with like the chatbot, for example, that Charles chatbot, each inference alone takes about 12 seconds. And it's very slow. Now you could inference in clusters and like batches, and that's a little quicker. So again, this is single inference. What I'd really like to see is someone break down like bulk inference, maybe like 5 inferences at once or something like that. But again, I'm not sure what the use case necessarily would be other than for training. So for fitment purposes, I wouldn't mind seeing train times with like a batch size that's realistic to what people tend to use, like let's say 32 or something like that. I'm not sure who they is as far as stealing your model in TensorFlow.js, but yeah, the model is downloaded locally, so the model gets downloaded to the person's phone. So yeah, if you wanted to, for whatever reason, keep like your model proprietary, you could, but models. If you want to protect your model, you're gonna still have just no different than anything really. Like if you don't want clients running it, you've got to run it on your server always. Sentdex YouTube really doesn't like your age. I'm not sure why you're saying that. What do you mean? Do you talk on the Discord? He generally doesn't. I don't answer technical questions on the Discord, but if you come into the general chat, I definitely talk there. Can you make a video for the path to deep learning? Honestly, I think the path to deep learning is just, I would go through the series here. I mean, like you don't necessarily have to start at the basic level, but so with machine learning, this series runs through pretty much everything. So this is just machine learning stuff. But then if you wanted, you could start at the deep learning part. But the path to deep learning is going to be different for everybody. There's really no one set path. There's no way. You're not going to learn deep learning by following someone's specific path. Like the way you're going to learn is by working on projects or doing your own research. There's no way you're going to get around trial and error when you're learning something complex like that. How do you recommend someone learn programming? If they have the logic but issues with the syntax, just use Google. I mean, there's a lot of times I don't know how to do the syntax, but I know what I'm trying to do. I just Google it. Eventually you either do it enough to where you remember it, or you don't do it frequently enough to justify storing it into your memory, so who cares? But yeah, just Google it, I guess. Learning path through all of ML. I mean, you could try to learn a bunch of like, something really like you're just not going to learn all of ML. I think that's like you can learn general stuff about all of ML, but if you really wanted to have like a strong understanding of like all the things ML, good luck. I mean, people are dedicating their lives to like one specific facet of ML. The only practical uses of ML I see are advertising or prediction type services. I mean, that's basic. I mean, ML does a lot of prediction, but there's a big difference between predicting, say, where the car should drive versus predicting what kind of movie you might like, right? To me, there's not much social value in necessarily. One could make the argument, but there's not much social value in like having a service that predicts, what movie you like at a difference between 85% accuracy and 95% accuracy. But when it comes to like self-driving cars, let's say, using like deep learning, for example, to, get it right 99% of the time, that's super important and also has a lot more social value. Show me your desktop wallpaper. So, I could minimize, but you'd only see the one screen. So, it's like a NASA image. I want to say it's Andromeda. You can find it. I think it's like HOSA on NASA. Yeah, this is it. I'll pull it up. Copy image address. It's a big image, probably not recommended to actually have as your desktop background. Let's see. How do I get to that? It's so tedious to get this exact image. Let's see if I can pull it up. Here we go. Credit card number. Yeah, there you go. That's my desktop background. It's a good size because so I have 4 monitors, and this is enough to blow up because I don't have them like 1, 2, 3, 4 like all linearly. There's like one on top, one here, and then one on each side. How many hours a day or a week do you spend doing extracurricular studying for programming, non-job related? Basically, all I do is non-job related. I don't really do that much contracting, consulting work, so I don't know. A lot. Most of my day is just screwing around with programming. I feel like we get this quit. The difference between like AI, ML, and deep learning. So AI doesn't have to be machine learning. AI could just be logic based. AI is anything that's artificially intelligent, period. Could be a bunch of if statements. Machine learning versus deep learning. Like deep learning is what you're doing with like neural networks, multi-layer neural networks. Machine learning is using a machine to fit some data. Ever been to Clear Lake, Texas? Yes, I've been there. I've been pretty much everywhere in the state of Texas, which is a big state. If you guys didn't know, Texas is like 4 times the size of all of Europe. If you look at it on a map, it's wrong because like maps are like flat and square. But if you were to actually draw a map to scale, that's how big Texas is. What's your source of income? I'm starving. You click that beautiful blue sponsor button under the video. Have you considered other libraries like Theano? Don't think I'll do Theano. It doesn't appear to me that Theano's getting anywhere. PyTorch, if I was going to do another library, it would be PyTorch. My ears died. What's your main interest in programming? At least right now, doing like applications with machine learning is cool. What are these like homework questions? What's the difference between test set and validation set? In general, your validation set's probably what's being run each loop. So you're just validating there. Whereas like your test set's like totally out of sample. Your like validation set, you're checking that every iteration. Whereas test set is like when you're all done training, you're not going to train any further. You check your test set. You kidding me on the size? I mean, I don't know. I'm pretty sure it's like 4. It could be 5 times as large. I don't know. It's very, very large though. Texas is no way bigger than Europe. No, it's like 4 or 5 times the size of Europe. It's because of the way the maps are drawn. It's absolutely massive. Are neural networks ML? Yeah. Where should I start with AI? That's wrong. No, it's definitely 5 times bigger. We got some people triggered in the chat. Here, I'll find a picture. I'll find a picture for you guys. I'm just not finding the photo I'm hoping for. So most maps of Texas just like aren't drawn to scale. But here's a properly scaled image of Texas. That's a satellite photo. So like when you see most maps, they're not like satellite. This is the real deal. This is like from a plane, I think, or a satellite. You know the deal. I'm going to try to find one overlaid over Europe. Most of the ones I see are just like those drawn maps. Obviously, super problematic. Man, I just cannot find the actual image I was looking for. I've seen one image that's like just Texas is like way bigger than Europe, but I'm just not finding it. It's probably been removed because people get angry about it apparently. You can't handle the truth. Actually, so the one I showed you is older. It's since been updated. This is the current situation. It's not virtually all of Europe. I mean, it's like 7 to 10 times the size. TensorFlow.js. Actually, it's TexasFlow.js. You missed the last 20 minutes. You didn't miss anything. How'd you integrate Charles AI to Twitch and Twitter? Twitch and Twitter API. Somebody needs to find me that photo. I used to always be able to Google image search Texas versus like Europe, and it would be like a gigantic overlay of Texas over Europe, but I can't find it. It's just unfortunate. Maybe I'll have to Photoshop one or something. Let's create a model that shrinks Texas. Yeah. Okay. I think we're all set on the TensorFlow.js and the size of Texas. I think we've all agreed that Texas is much larger than Europe. Anyway, if you guys have more questions, you can post them. Once this video gets posted up, you can leave them below. Otherwise, next week we'll get into doing the Pong AI with TensorFlow.js. Both just collecting that data, training that model in like something like Keras or something like that. Keras is like super simple. And then importing that into TensorFlow.js and then using that with our model. And then possibly in that same tutorial, we could probably get into using like transfer learning to hopefully get that model to be a little better. You can't just train it raw based on like a couple of gameplays. You'll never, like, you just can't collect enough data to get a good model unless you're planning to play it for like 10 hours or something like that. So anyways, that's all for now. Thanks for dropping by, everybody. Thanks again for the sponsors, Daniel, Alan Wang, and Lunsterful. Till next time.